Okay.
Okay,
Great.
cool. Thank you.
Okay, so and another thing to add, if you want to follow along with this tutorial as I'm going through the steps, you can refer to the article. It's called An Introduction to Contract Development on Neo, and it's on dojo.coz.io. And let me pull up the chat and I can throw the link in there really quick for everybody. So we'll be largely following this tutorial for today. We can go through some more details if there are any specific questions, if that works for everyone. Okay, so here's a raw project. All I've really done here to save time is create a directory called Hello World. And then I also have this HTML directory and a smart contract directory. The smart contract directory and HTML directory are just, for me, they're not necessary for this tutorial. They're just kind of how I like to format these types of things. So one thing that's, I think, important to understand when building on Neo is how the applications will relate to each other, or the various components. So in this tutorial, architecturally, we're effectively like in a standard client-server relationship for a platform. We're replacing the server with the blockchain. Now, depending on the complexity of the platform that's being used, you may have a dedicated backend as well, which interfaces in concert or works in concert with the blockchain. However, for this kind of architecture that I'm going to be working with, where the entire backend is on the chain, and we're really just interfacing with it with a client-side application. And in this case, it's kind of the lightest of lightweight. There's going to be a button with a contract invocation. Okay. I'm not going to go through some of the architectural components of the Neo platform. I think there's plenty of content out there for that. And it's valuable for development on the Neo in the Neo ecosystem, but it's not necessarily critical for this tutorial. Okay, so another thing that I think is important is which tools we're going to be using. As I mentioned, we're going to use Neoexpress, Neonjs, and Boa. For this tutorial, we actually don't need to install anything on the JavaScript side. So we really just need Boa, which requires Python 3.7 or above, and then Neoexpress, which requires .NET. I think it's important to note here that if you're in a Windows environment, the setup is pretty straightforward, obviously with .NET. If you are on Mac OS, the setup for Neoexpress it's still relatively easy. There are just some considerations. The main difference is that you're going to have to install a few extra dependencies, specifically RocksDB. Okay. So here I'm going to install, and again, I'm pretty much doing this from scratch. I have .NET installed and I have Python installed. So one other thing to note, and I have the release or the pre-release tag here. Something to pay attention when you're installing these is which release they are. Since we're at an RC level with N3, you'll probably want to use whatever is relevant to testnet. So in this example, right, you can see here in the release notes that we're on, this is an N3 RC3 compliant release. If you encounter issues one thing that we at COZ have been encountering, for example, is if there's an update to this, you'll want, and you're running into interfacing issues, you'll want to uninstall the tool from the previous version. So you would do .NET tool uninstall neo.express, and then you'll want to reinstall the new version. We're releasing, you can see here, this is 4 days ago. The last one was 13 days ago. May 17th is when there was an RC2 release. So definitely check that versioning if you are running into some interfacing issues, since that's pretty, that's going to be a pretty big cause. And I'm going to do my first issue here. And of course, yeah. Sorry about that. I had an extra colon, and we'll just do I'm going to copy it. Since I'm notorious in the Neo ecosystem for typos. So in some cases, copy and paste works a little better for me. So we'll wait for that to set up here. Okay. So that was really complicated. One of the things that's really important with N3 that's a little different from the Neo legacy kind of experience is the focus on ease of use. So there's been a huge push from the entire community to really make things a lot simpler. In the Neo legacy ecosystem, if any of you are familiar with it, some of the processes were rather laborious and required some niche understanding of how things behaved and operated. We've really tried to abstract a lot of this behavior so that it's a lot easier to use. So if you're not familiar, Neoexpress is a private net ecosystem for developers to run actually locally, but then also if you wanted to have like a staging environment or something like that for your team, it can also serve that purpose. Okay. So the next command that we're going to run now that we have Neoexpress installed is neoxp create. And what that's really going to do is it's going to initialize your private net. And up here, you'll see, so I'm in this hello world directory. We've got this file called default.neoexpress. And if I open it, you'll see all of the configuration information for our private net. We'll have this magic number, which is really important for people to be aware of. You'll definitely want to, and I'll mention this a little later on in the tutorial or the workshop, but it's primarily I don't want to call it a security measure, but it's a safety measure in part. So this number is going to be different from network to network. So whenever you spin up a new private net, for example, that number will roll or change. And likewise, that number is going to be different on testnet and mainnet. So if you're having interfacing issues, make sure to check that magic number, because your transactions are going to will be rejected effectively if that's not correct or accurate. And again, that's primarily a safety measure to prevent accidental crosstalk between, for example, like testnet and mainnet, right? You don't want to, if you happen to use the same wallet for both or address for both, key pair for both, you don't want to accidentally send what you thought was testnet Neo, for example, to a mainnet address in testing. We have had that happen in the ecosystem in the past, so that's a pretty nice addition to N3. Okay, some other information that's important. We'll skip some of the other ports. Your RPC port defaults to 50,012. That's an important number or port number that we'll be using as part of this activity as well. And then you'll also see the accounts that were created for this private network. Okay, so now that we have our network initialized, we're going to run it. So we're going to do neoexpress run. And actually, let's do this. We're going to run that in our neoexpress terminal tab here. So we'll just do neoexpress run, and I'll show you guys a couple things that are useful here as well. Although again, at kind of a 1 hour workshop level. Okay, so after running that command, you'll see it spinning up the private net, and you'll start seeing information about the network now. In this case, I'm just using the default configuration. You'll see it spitting out information about the blocks that are being minted and committed to the chain. You'll see the height information being published. And then you'll also see, which is for me useful as kind of a sanity check, you'll see the transaction count. So that's 0 right now. We will be issuing transactions to this private net in a second. Okay. So for the sake of time on this, since I'm trying to move fast so we can get to some Q&A to try, to help answer some specific questions. And I saw that there are some other folks in the call that can also help if we get stuck. If there are any issues, you can ask them and I can circle back to answer the questions if I'm unable to answer them. I'm relatively familiar with this content, but we definitely have, there are some people within like the COZ team and the Neo ecosystem in general that are really adept at this specific type of content. So I can make sure that if those questions are forwarded correctly if I'm unable to answer them. Okay, so let's talk about the Neo 3 BOA now. I guess I was a little misleading previously when I said I hadn't installed anything. I have installed Neo 3 BOA, but I think since we're going to be setting up an environment, like a virtual environment for it, it's probably not relevant because you're going to go through the same experience anyways. So here you're going to want to hit Python, whatever your Python 3 alias is. So I'm just going to create a Python virtual environment. I won't go through the details of why that's valuable. And again, I'm on Windows, so if the commands look a little different, that's why. Okay, so now we're in our Python environment, and then we're going to install with pip Neo 3 BOA. And this, I'm literally just running through the quick start here. Yes, you can use NeoExpress and Docker. There's also, there are also, I believe, images published of the Neo platform itself that are Dockerized. So you have a few different options there if you really want to containerize everything, control it all. So this is going to be relatively straightforward. We have, the Linux and the Mac OS and then the Windows instructions here for setup. Once you get through the virtual environment component, which is recommended, not required, everything else is going to be identical, right, with pip and everything. These instructions, by the way, for how to get started with BOA, I mentioned this article link at the very top here. You can click on the BOA link, and that will take you to the setup for that. I should also mention that those links are also available in these articles here. So we have BOA install, here's the NeoExpress link, and then here's also Neon.js, which is optional. Okay. All right. So we have Neo 3 Boa installed, and this does have a command line exposure. So if you type Neo 3 Boa, you'll see, and forgive my really slow environment here. Okay, so I think the next thing for us to do is go through the contract. Let's see, where are my notes here? Okay. Actually, I forgot one step on this. We actually need to create our wallet and then transfer some tokens into it. You can deploy, you can use the Genesis account to deploy smart contracts, which is the one, it's like the default account. And like that key pair. I don't think anybody in the ecosystem with much experience would recommend that. And the reason I say that is primarily from a security perspective. If you're using the Genesis account, there's a lot more potential for exposure for that. I might actually recommend creating an account for Neoexpress to use specifically for this. That way you're just aware of it, and then using a different account every time you deploy. So maybe saving that or using an environment variable to cache that data would be probably the recommended approach, since again, depending on what your level is, you may be familiar with this, but if this information is shared, you're kind of hosed. So it's something to keep in mind, that we want to keep that information secret and safe. Okay, so to create a wallet, we're going to do Neoxp, and I'm doing this a bit from memory here. I guess I should probably jump back, and I said I was going to do the accounts first, but I should probably follow the tutorial here. So we'll go into the smart contract folder, and you can name this whatever you want. I'm just, we'll call it hello. There's my first typo of the day. Hello world. Okay, hello world.py. With Boa, you're really, and I mentioned it's Pythonic. So I'm literally copying and pasting at this point for some of this code just to save some time. So we have our import statements, just like a typical Python project. In this case, we are exposing the public functionality, and what that's going to allow us to do is define public methods. And by public, what we mean is that they're registered on the API, so you can actually invoke these methods. And I'll show you. So if we do init, the return type is also not a requirement. I think it's just a lot clearer for people, for me to have that in there. And then we're gonna do hello Neo. Okay, and then we're gonna do a return. And before going to this second method on here, I'm going to describe what's going on. So you'll see this public designator or flag is on this init method. And what that means is that it's invocable externally outside of the smart contract. It's not a kind of a global method or exported. If this were removed, you would only be able to interface with this method within the smart contract, right? So that's kind of an important thing to be aware of. We're initializing the smart contract, which is arbitrary method name. This put is a really critical one for people to be aware of. And again, there are analogs for most of these methods in every other language that's supported. The one thing that I think is important for people to be aware of with Neo is that Neo operates off of a virtual machine kind of architecture at its core. So any language that people have written a compiler for, or effectively a translator from that language into, Neo VM bytecode, can be used to write smart contracts. And this is relatively valuable. A really solid example of this would be using some of the languages or examples that are in like the Ethereum ecosystem, for example. So like Solidity, for example, to some extent, it is possible to have a Solidity compiler for the Neo VM. Now, of course, like some of the architectural nuances for that language would be difficult to support, but we can get relatively close with a lot of the syntax. So that's kind of the same with Python. So we can build out, and this is why we call it Pythonic, because it's not true Python. It's a kind of a derivative or an analog to it, where we've used the Python syntax and experience to try and bring that to the Neo ecosystem, right? And that's actually the same for .NET, the .NET experience. That's also going to be the same for like Java, Kotlin, and Go, as well as TypeScript as well. Okay. And then obviously we have our return, and we'll do a return true. Sorry, my JavaScript is getting to me here. Okay, and then we're gonna have our second public method here, which is gonna be def, and we'll just call it hello. We're gonna return a string here, and we'll just say return bytes. Okay, so here's our second storage method, and I guess I should mention that. So the put method, what it's really doing is it's storing a key value pair into the smart contracts scoped storage. And I think that's important to note that, it is scoped, and we do operate in kind of a key value architecture. However, that's not really limiting. There are a number and have been a number of projects in the ecosystem to add additional functionality to the storage for more advanced functionality as well. So in this case, the put method is storing the key hello with the value neo. And then here in the hello method, we're getting the value of hello, right? And I think it's important to note that storage is in bytes, right? So then we're taking that bytes and we're converting it to a string for response. One thing that people should be aware of is what the responses types are and the formatting, just because we are going through multiple presentation changes within our smart contracts and our SDKs and things like that. So occasionally that can be an issue for developers. Okay, and for this contract and for this tutorial, this is actually where we're probably going to stop with the code for the smart contract. I will note that, so that link that I sent on Dojo, if you click on BOA, there's a pretty large selection of examples, and I can show that here really quickly. So if we go in here, you'll see there's a tutorial tab, and you'll see multiple examples here that are even this, like the quick start one. So here's a NEP17 token. The examples are far more complicated than what we're going through today and more involved, and they show a lot more functionality. There's obvious time constraints here. So you'll notice there's a lot more going on in these smart contracts, with more examples being published regularly. We even have a wrapped token example as well, right? Another good reference point that I use a lot. So we have this code reference, and it just shows a bunch of examples of the basic functionality, which is supported. We also include, and this is kind of a hidden area that we're going to work to expose more of, but for people to be aware of. So this is our test directory for the actual project here. And you can see there are a lot of functional examples that we run in our test environment that show and kind of illustrate specific functionality. This is also really valuable. I should mention that we do have, like, there is our doc string as well that people can reference. So if you go in here, look at, like, where do we want to go? Maybe crypto. You'll see, so here are a bunch of like hashing algorithms that we've added as well for support, right? So that's also available to people, and that's in the package reference. So there are quite a few places for people to look at if they have questions. And again, we also have the Discord, we have the forum. We've worked pretty hard to expose support where needed. Okay. So now that our contract is written, we're going to compile it. And technically this is transpiling, but we don't need to get into that. So we're going to go Neo3 boa, and then we're going to really just feed it this Python file. So where are we? Okay. And you'll see that it's going to generate a bunch of extra files here. We're going to kind of ignore those for the time being. They do have a lot of value. The manifest is particularly useful, just as kind of for your purposes. It's really good for kind of just a check to make sure that everything looks right, since it's going to include your method definition, right? And that's really important, just to make sure, like, again, if you're having issues interfacing with, if you're having interfacing issues with a specific method, you can look here to make sure that it's exposed. Okay, so that is our smart contract, which is now compiled and ready to deploy. Okay, so to create our smart contract, or deploy our smart contract on the network, we're going to need an address with some gas in it. So in Neo, we have a 2-token model, right? We have Neo and we have gas. I won't go into the details about why that model is valuable, or why it's used. But for the sake of this conversation, gas is the token that we use for interfacing with the network. So we're going to create a wallet here. And you'll notice you get the address, and you'll also see, the notification. The private keys for the accounts in this wallet are not encrypted. Use at your own risk, be careful. You'll also note, you can note that in this default.neoexpress file, you'll see here's a new wallet that was created with an alias COZ, and you can see here's the key information as well, right? I know I said don't expose this information earlier. This is a relatively closed or controlled environment. So, and I'm not planning on using the hello world contract for anything valuable. So we're good with that. Just breaking my own rules here. Okay, so the next thing we're going to want to do is transfer some gas from that Genesis account into our new COZ wallet. Gas Genesis COZ. right? And this would be the same thing. The Genesis account also has Neo. So if you replace this with Neo, you would transfer Neo, but again, we want gas. So we're gonna relay that transaction, and you'll see that it was submitted. And then if we go over to the NeoExpress tab, so our network, and we wait, you'll see we have a block that was minted, and you'll actually see now we have a transaction of 1 in that block instead of 0. And that's just a good sanity check. You can verify that the transaction was actually published to the chain. Okay. So now we're going to deploy our smart contract, and this is relatively straightforward. Again, we've spent a lot of time for this, especially from a tools perspective, there are changes, I think, all across the board. The Neoexpress tool, again, has been really great for the team. I think everybody in the COZ ecosystem or community uses it directly, instead of some of the Neo legacy experiences. Okay, so we have Neoxp, contract, deploy. And this time, instead of targeting, because when we used BOA, we targeted this Hello World Python smart contract, but now we're kind of in the on-chain world. So we want to use that compiled code that's available in this file here. And I'll open it, and you can see it's kind of meh, right? I won't go through the encoding to show you what that looks like, but okay. So we do NeoExpress contract deploy, and then we're just going to target that nef file here. Oh, sorry. I forgot to mention I need to provide an account to pay for that deployment. So you'll see I'm adding COZ to the end there. Okay. So that's submitted. And then again, I think it's good to go over here and we can look. And then you'll see there's our transaction 1, kind of implying that it was deployed. One other thing that I think is valuable to do is to go in here and just verify what it is. So if we do NeoXp contract list, we'll see all of the contracts that are deployed on our network. So here you'll see all of our native contracts which have been deployed, right? Our oracles, our policy, gas and Neo, obviously important. And then the other ones are also important. Those are just ones that I think people are probably more familiar with. And then we have Hello World, which is also deployed. Okay, so there's our smart contract. This is important because it's your script hash. So this is kind of it's the address that's used to reference this Hello World smart contract. So when you're trying to invoke the smart contract from, say, neon.js, for example, or even a wallet, at a higher level, you're effectively addressing or targeting this smart contract that we've just written, or that you've written for the Frontier Hackathon using this script hash here. Okay. So the next thing we're going to do here is we're going to show the first mechanism for invoking a method on the smart contract, and we're going to do it twice. Okay. So the first method we're going to invoke is that initialization method right here, which is going to store data into our storage, as we mentioned earlier. And the way we're going to do it this time is we're going to create a file. And this is a really good way, by the way, to set up things like unit testing. This can work really well for that. Or I guess technically it's an integration test, but this can work really well for that. And we're going to create and we'll call it like hello world init.json. Okay. And in this file, we're effectively going to define what the invocation looks like. And in this case, I copied and pasted for risk of error. And you'll notice there's this contract script field. So we're just going to take this and we're going to stick it in there, since that, you know, the invocation, it needs to know where to target. And our operation is in it. Now, if we wanted to invoke this hello method here, we would just input hello like this, right? And then when we ran it, it would invoke that method. Likewise, any arguments that are required by the method, you would populate here. Okay. Great. So now to invoke this init method from within Neoexpress, we just do neoxp contract invoke. And we are at smart contract / hello world init.json. Okay. Oh, and again, I'm forgetting the account here. Now, I think I'm trying to kind of pay attention to what you guys are talking about in the chat on the side here. I think it's important to be aware that there are a bunch of different ways to interface with the network and also the smart contracts, not just from a language perspective, since we have SDKs in a lot of the primary kind of popular software languages right now. But I actually mean what the mechanism that's used to actually relay the transactions are, and whether we actually relay a transaction. We have free transactions, for example, if you don't need to change or update the state of the chain, right? So if you're not updating storage or doing anything like that, or if you don't want to publish a transaction, in many cases, you can run what we'd call like a test invoke, which is free, and that's actually we're not really going into the details of that. There are articles. There's actually an article that was just published on that Dojo website yesterday, which explains this in more detail. But it's important to be aware that there are different mechanisms, and some of them are free and some of them cost gas. They can be used, you can optimize your gas costs depending on your situation. And in many cases, dApp developers in this ecosystem will architect their apps around this concept in order to minimize transaction fees. If you can pull data directly out of storage, for example, or invoke the methods without publishing a transaction, it's cheaper and it's better, for the chain in terms of traffic, right? And as I mentioned, there is an article for that, and I can throw that up here really quickly for people to look at. It looks like somehow I got stuck in there we go. Okay, so we've run this transaction, and I didn't show you guys here, but there's a transaction somewhere down here. There it is. So this was our invocation. We just, I got a little verbose on there. Okay, so that was our first invocation, and that was what would be called like a publish transaction, right? Or published invocation, since we did change the storage state, which impacted the chain. The next one, this is actually a test invoke, or what we would call a test invoke. So it's actually, it can be a free transaction with zero cost because we're just reading out of storage. And I should also note here that there are multiple ways to read out of storage as well. You can actually directly read the storage of a smart contract. That can be useful depending on what you're doing, especially if you're trying to sync or mirror storage across like chains, for example, or across platforms if you have a dedicated backend. In this case though, and generally I recommend using your methods on the smart contract, just because there's no, it's generally a good idea not to make an assumption that there aren't any business rules associated with the storage, right? If there's any kind of manipulation that's required before digesting the data, you're losing out on that if you just directly grab the content out of storage. Okay, and then for the sake of time here, and I'm seeing that we've got a couple devs, ecosystem devs in here also providing some support with the Q&A, which is really appreciated given the time. So we are going to use our published version of Neon.js. And again, I'm going to copy and paste just for speed. So we do publish and list on Unpackage a version of Neon.js that can be used if you're doing a really lightweight app. You don't want to have a build process or anything like that. One thing to be aware of is that currently, if you do want to work with kind of what we're considering Neo, to make sure that you're using the next package, this may be an area for confusion for some people. There is also the regular Neon.js package, and this also applies to anyone building in like a node environment. And the reason I mention that is that the default package currently is for Neo Legacy. So you're going to be using tools which are not going to be supported by the chain. So the communication is going to be different, and that may be an area of issue for people if you're getting stuck here, where the next package is designed for N3 and Neo moving forward. Our node URL, so we're on localhost. This is that RPC port. So depending on the tool that you're using, for example, if you're using NeoMamba, which is our Python SDK, you're going to be communicating both on RPC and TCP. For most interfacing, especially if you're building a dApp, you're probably going to be using this RPC port here. And for information on that, as we go into testnet, you can actually go to, we have a monitor set up on Dora, right? So if you go here, you'll see all of your testnet nodes that are running, including the port. So as you start to build these contracts and tools, if you're planning to deploy to testnet, you can reference this monitor page in order to access the nodes on the network. Okay, and we have some statistics and information that we publish as well here. Some of this content takes a little time to be updated. So that's a useful tool for people also as we start to talk about like taking your contract out of the private net environment and into kind of a staging or a production ecosystem. Okay, so we've deployed our contract, kind of back on topic. And I remember I mentioned the address to the smart contract. So that's this one here. And we're going to update this address for the smart contract. So here's our script hash here. This is where we're targeting. And then all we have here is a really simple button that says hello, right? And then we have an empty method here that's just called hello blockchain. Okay. And I think our goal here in the next 10 minutes is to interface with the smart contract, extract this this value Neo, and then publish it. Okay. I feel like I missed showing you. One second. What is it? It's Neo. Sorry, I'm going to do this off the top of my head. New contract show storage. No. think it's just neo contract storage. That maybe. Yeah. Okay. So what I wanted to show you, so remember we invoked that smart contract with this init method here, and that should have created this key value pair entry, hello Neo. All I'm showing you is this is the actual storage for the smart contract. So here's our contract name and the key and the value. And it doesn't look like a lot, but I'm going to show you guys. So if we take that hex data and we throw it in into a converter here, and I'm going to clip off the designator, you'll see it says Neo, right? And that's going to be the same for the key, right? So if I do this one, it should say, hopefully it says hello. Yeah. So if you see stuff like that, you know, hex is kind of the bread and butter of the ecosystem. So, you know, don't be disappointed if you see a bunch of hex. It's generally you're just dealing with an encoding difference to work through. Okay. So that's kind of an important, again, just sanity check in our ecosystem. Okay, so I'm going to, again, pull some code out of our tutorial here. And I'm going to replace this method with this invoke. Okay. So here we're building up our intent, and you'll notice that this is actually identical to what we had in that JSON file, right? So we have our contract hash, our operation, and our arguments. And over here, you'll notice the same thing. We have our, with slightly different nomenclature, right? So we have our contract hash, in this case, our hello method, and then our parameters. And throughout the ecosystem and all of the tools, you'll probably see a very similar format as well. So you kind of become familiar with these things if you're interested in using multiple languages, which for more advanced contracts or platforms, you probably will. Okay, and in this case, we're going to build up our facade for the network, which is really, in this case, just defining which node we're going to target, and that's just this computer on port 50,012. Okay, and then all of this code from here down is extra. This is actually the method we're calling. So we're calling facade.invoke, and we're going to feed it this intent. And the response is going to be that invocation response, right? And I'll show you that in a minute. So we'll just really quickly here, I'm going to add this in there to show you guys what that looks like. And then we're going to do, we're going to pull some values out of the stack from the response, right? We're going to have to decode it since the endpoints 4 and 3 are base 64 encoded, right? And then we're going to take that hex string that we have down here now, and we're going to convert it to ASCII, and it's going to display, hopefully, Neo. We're also going to get the block height really simply, and then we're going to stick them in these two divs right below the button. Okay. All right, now let's try not to expose my desktop doing this. All right, so here's our little button. Let's leave it in windowed mode so people can see. Okay, and I'm going to pull up the console here. All right, so then I'm going to press hello, and that should relay the transaction, and you'll see Neo. And this was actually the response from the smart contract. So that's our first invocation on the blockchain to a custom smart contract. Now, if you're interfacing with those native contracts I mentioned, right? any of these smart contracts right here, including our native Gas and Neo, that interface is going to be the same. So you can talk to, like, you can invoke the Gas and Neo smart contracts just like we invoked this Hello World contract, which makes things really easy. I don't know if people are familiar with the kind of the Neo legacy experience with UTXO. So in Neo legacy, we had a UTXO model and an account model. This has really simplified the development experience, especially for things like wallet providers or exchanges or anything really where you're interfacing also with Neo and Gas. So this is our raw response from the blockchain, right? There was no exception. This is our gas consumed here. And this, I believe, is in fixed 8, right? Notation. Now, again, this was a test invoke, so it was actually free. We didn't pay anything for that. You'll notice in our example code, we didn't actually provide it with even a private key to sign the transaction, right? This is just hypothetically, if you were to publish the transaction, that would be the cost. And again, this is in fixed notation, so it's a large number intentionally. Here's the invocation script that was run. And then here is our stack, right? And this is where all of your response information is going to be held. So here's our byte string, right? And if we were to take this byte string and again, decode it from base 64 and then convert it from hex to ASCII, you would get Neo as the response. Again, I think it's important to note that there are multiple ways to interface with the network. So a good continuation of this experience would be running through this tutorial, and we're not going to do that today, but it would be kind of a good next step. And in this tutorial, interfacing with smart contracts using Neon.js, we go through kind of the differences between the different invocations and when you would want to use one or the other, as well as how to do that within Neon.js on a NEP17 smart contract. So you'll see our Neon.js examples get a little bit more involved here as well. But there's nothing here that is fundamentally different from what we just discussed in this workshop. They're kind of building off of this experience. And again, everything here is also mostly available online. We just are, there were a couple developer tidbits as well. So thanks. I suppose there are 2 minutes left. Songping, I don't know if you wanted to do a brief Q&A or if you wanted to call it. Here it looks like the team is able to provide or has been providing a lot of support in the chat. So I don't know if there are any outstanding questions even.
Yes, I think a lot of questions have already been answered in the chat. So if there's, I think we still have time probably for one or two more questions, if there's any, like any participants here who would like to raise questions, please kindly raise your hands. The Zoom do provide this function, and I will unmute you.
Didn't even have time to drink my coffee during this, so. Okay. Great.
Or yeah, I don't see any. One more. Wait a minute.
Okay. Kinchuk.
Yeah, hi. So if you can share pointers on how to interface Neonjs with an actual wallet and invoke a contract or some references around that, that will be helpful. Thanks.
Do you mean for like signing a transaction from a smart contract securely?
Yeah, for a end user using the DI.
Okay. Yeah, so there are two approaches to handle this. One would be using, it's called DAPI or DAPI, which recently the N3 or the Neo version, the new Neo version was released. So you can reference that platform or solution. We also, if people are familiar with Wallet Connect, the COZ team, and actually Joe is here, and he's part of that team, we're about to release the Wallet Connect SDK, as well as a tutorial on how to use Wallet Connect with the Neo platform as well. And we're hoping to have that out, I think, this weekend or very early next week. And that should resolve that issue as well. So there are actually two different solutions in the ecosystem that can be used for that. That issue of exposing private keys is a pretty big one, right, in this space. Thomas?
Thanks, Tiger.
Mm-hmm.
Yeah, I have another question. Can you maybe tell us what the correct way is of setting a admin key of a smart contract? I'm not sure. I all seen the uint 160 with the brackets, but what need to be put inside it? And where do I get it from?
I'm sorry, I didn't catch the part about the brackets.
There are some examples. For example, some Net11 contract, and there's an admin key, and it's specified with uint 160, and there's some brackets. I need to put something inside the brackets, I think, to set the right admin key, but I don't know what to set inside these brackets.
So you're referring to, yeah, let me pull that up really quick. So you're specifically referring to this kind of like this piece here.
No, not this. I'll try to share a link. Give me a second. When we take a look at this contract, there is contract globals, and there's one part with the admin key.
Right. So this is an important concept, and that's actually a really good question. What you want to put there, you can either, and I think in this contract it may be available or listed, which can cause issues. That is a development architecture that I like to go with, where it's actually a second administrator or owner private key instead of the default one, which deployed the smart contract. What you would want to put there is this is actually, now that we're going into the weeds, this is actually a little more complicated. So what you'll want to put in there is your escaped and reversed hex code for your public key, right? And if you can post, if you send me a private message with either your email address or your Discord handle or something like that, I can send you a code snippet. But what you're effectively doing is you're doing a reverse 2 bytes in Python of your public key. And that will export your escaped and reversed public key to populate there. If you want to, and for everybody that's on the meeting or in the call, what Thomas is asking about is how to embed a public key into the smart contract for use. So if you wanted to have like a third-party check witness or a check witness against like a hard-coded key, for example, instead of using something that is kind of invoked. And in some cases, this can be useful. In this specific case, it can be helpful for development purposes. So yeah, maybe I'm trying to think of a good way for us to send that information out. let me grab this really quick here. I might have it. Yeah. So here is kind of what you want to do. So if you look in the chat, I sent a bit of an example there. Right, so you'll notice that I've clipped off the 0x designator. Right.
I can see messaging.
So, and that's in Python, right? So I'm doing bytes from hex, and then you get this this binary formatted string, right? And then that's what you would use to hard code a key for something, you know, so you could use like check witness on it against it and things like that, and it would operate correctly.
Okay,
and that's a really good question. That's one of that's a bit of a dangling issue actually from the community. Regarding the C# implementation, I propose posting that in the dev general channel. I'm relatively familiar with C#, but it's all a Neo legacy, so I wouldn't feel comfortable commenting on the kind of new Neo experience, which may be slightly different. So I believe that in C# though, if it hasn't changed, you would just directly populate the key, although I'm not positive on that. Somebody may. Yeah. Exactly what Joe said, better. So, all right.
Thank you.
And again, I think, you know, thanks everybody for attending. If there are any other questions, feel free to tag me on Discord or post on, you know, our forum at forum.coz.io. You know, I think the community, especially like Joe and Harry, have been really amazing with providing support so far. And, you know, you can also feel free to tag me if there are any questions about this tutorial, and I'll also quickly respond or try to respond with an answer. And if I don't have it, I'll try to get you one from the community of experts. So thanks, everyone.